first of all, if you just glance at this, what does this look like to you in just very general terms? What does it look like? Some kind of what?
A mess.
A what?
Mess.
It's a mess. What else?
It's like saying conservation.
It's
energy.
conservation of something, right? Didn't we have L final equal L initial, and P final equal P initial, and E final equal E initial, and so on? So this is some kind of conservation of something equation, where what I start with equals what I end up with. That's the first thing to notice. The second thing to notice is that this looks very much like what, but isn't quite like that.
It looks very much like that.
It looks like what?
Like kinetic energy. Like
It looks
MV
very much
squared.
like a kinetic energy term, right? 1/2 mv squared. But that's rho, so that's kind of weird. And this looks very much like, what kind? Say it.
MGH?
MGH, potential energy, yes? Okay, but it's got a rho in it, correct? So if I ignore the pressures for now, it looks very much like conservation of energy, total mechanical energy. But this is per unit volume, so this is joules per meter cubed. And this is joules per meter cubed, because isn't mass over volume rho? This is conservation of energy density. That's all it is. For flow of a fluid in a pipe that has varying height or varying potentially cross-sectional area. The P here, this is absolute pressure. And I'll tell you a common mistake in doing problems related to this thing, which is called Bernoulli's. I think I'm spelling it correctly. Equation. A common mistake here. Remember we talked, oh, question?
So there's the one on the right and the one on the left, and they're very similar, but they're different. Are we supposed to know both of them, and then are they for
The one in the box over there?
Yeah.
Looks just like that one.
No, it's an M instead of a rho for the GY.
Oh, that's just a mistake. Sorry. Because yeah, it's fine. Sorry. M over V. You need to know this one. So this is Bernoulli's equation. Common mistake here is the following. Remember we talked about this idea that P2 is P1 plus rho GH. Remember that? These two pressures are these guys. And these two positions will determine the relative height of the liquids for you. Please do not double count by trying to say, oh, well, P2 is lower down, so I'm going to go ahead and add something to this term to adjust for that. These guys here will do that for you. They'll take care of the rho GH part for you. It's a difference in height between P1 and P2. This is absolute pressure. The best way to figure this out is to do problems, and I'll show you exactly how to do this. Okay? But big ideas. Conservation of energy density. This is like kinetic energy per unit volume. This is potential energy per unit volume. This is also energy per unit volume, believe it or not. But it's work energy per unit volume. Force through distance divided by volume. Okay? So, I've warned you about that mistake. We'll do probably 5 problems where we work with this thing so that we don't screw it up. Okay?